Hello and welcome to Astronomy Daily. I'm excited to bring you another fascinating roundup of space and astronomy news. Today we have another great lineup of stories that showcase both human ingenuity and our expanding understanding of the cosmos. We'll start with the dramatic rescue of two astronauts who were stranded in space for 9 months and explore what this means for the future of space law and rescue operations. Then we'll look at some cutting-edge spacecraft technology being developed in Europe that could help solve our space debris problem. We'll also dive into the preparations for Dream Chaser's historic first flight, examine groundbreaking new images of our infant universe, and explore intriguing new theories about how life began on Earth. Plus, we'll look at ambitious plans to mine valuable resources on the moon. Stay with me as we journey through these remarkable developments in space exploration and discovery. And of course, I'll kick things off today with the story the whole world seems to be talking about. In a significant development for space operations, astronauts Suni Williams and Butch Wilmore have finally returned safely to Earth aboard SpaceX's Dragon capsule after an extended 9-month stay on the International Space Station. Their prolonged stay wasn't planned. It began when their experimental Boeing Starliner spacecraft experienced malfunctions last June, making it too risky for their return journey. This unprecedented situation has brought to light critical questions about space rescue operations, particularly as we enter an era where space travel isn't limited to traditional astronauts. With civilians like William Shatner, Jeff Bezos, and Richard Branson already venturing into space, and celebrities like Katy Perry and Gayle King planning upcoming flights, the need for clear rescue protocols has never been more pressing. The challenge lies in the current state of space law, which hasn't kept pace with the rapid commercialization of space travel. While international space law requires countries to rescue astronauts regardless of nationality, there's significant uncertainty about whether private space companies have similar obligations. This legal vacuum becomes particularly concerning when we consider the growing number of space tourists. Space policy experts are now calling for two crucial reforms. First, a broader interpretation of the term astronaut to ensure rescue rights extend to all space travelers. And second, clear guidelines determining responsibility for rescuing private citizens in space emergencies. The pressing concern is that, without proper oversight, space tourism companies might require customers to waive their right to rescue, a potentially dangerous precedent. This rescue mission's success is certainly a relief for NASA, but it serves as a wake-up call for the international space community. As we continue to push the boundaries of space exploration and tourism, we need to ensure our legal frameworks evolve to protect everyone who ventures beyond Earth's atmosphere. Let's turn our attention now to another pressing problem in space. A group of European companies has embarked on an innovative project to tackle the growing challenge of space debris. Led by Portuguese startup Spacio, the consortium has secured €3 million in funding from the European Space Agency to test an inflatable drag sail designed to help satellites return to Earth more efficiently. This groundbreaking system starts at just 20 square centimeters, but can inflate to an impressive 1.5 square meters once deployed. The dramatic size increase creates significant atmospheric drag, allowing satellites to deorbit much more quickly than they would naturally. Instead of taking a decade to burn up in the atmosphere, satellites equipped with this technology could complete their descent in just over a year. While the initial test will involve a relatively small 12-unit CubeSat, the technology has potential applications for satellites up to 200 kilograms. What makes this system particularly valuable is its ability to function even if the satellite itself fails or malfunctions, unlike traditional propulsion-based deorbiting methods that require the satellite to remain operational. The SWIFT project, which stands for Spacecraft with Inflatable Termination, brings together expertise from across Europe. French company SpaceLocker will handle integration, Dutch firm GomSpace will provide the host satellite, and Solid Flow from the Netherlands will develop the critical gas generation system needed for inflation. This development comes at a crucial time, as the number of satellites in orbit continues to grow exponentially. By providing a reliable and autonomous method for removing defunct satellites from orbit, this technology could play a vital role in maintaining the long-term sustainability of our orbital environment and preventing the accumulation of dangerous space debris. The team plans to demonstrate this innovative deorbiting system in low Earth orbit by 2028, marking a significant step forward in responsible space operations and debris mitigation efforts. In exciting developments for space exploration, Sierra Space's Dream Chaser spacecraft is entering its final testing phase before its historic first flight to the International Space Station. Nicknamed the Mini Shuttle, this spacecraft will be the first since the retirement of the Space Shuttle program in 2011 to dock with the ISS and then return to Earth via runway landing. The first Dream Chaser vehicle, named Tenacity, is currently in Florida undergoing crucial pre-flight testing. The spacecraft must complete electromagnetic interference testing and acoustic chamber trials to ensure it can withstand the intense vibrations of launch. These tests will verify that all onboard systems can function properly in the harsh environment of space. Tenacity will launch aboard ULA's new Vulcan rocket and carry over 3,500 kilograms of supplies and science equipment to the ISS. The vehicle is designed to remain docked to the station for between 30 and 90 days, depending on mission requirements. One of Dream Chaser's most remarkable features is its advanced thermal protection system. Unlike the Space Shuttle's mixed use of tiles and blankets, Tenacity is covered in approximately 2,000 specialized black and white tiles. These tiles can withstand temperatures up to 2,600 degrees Fahrenheit across multiple re-entry cycles, while also helping regulate the spacecraft's temperature during orbital operations. The vehicle's design includes several key safety improvements over the Space Shuttle. Dream Chaser launches inside a protective fairing, preventing the tile damage from falling foam or ice that plagued the shuttle program. It also uses a more environmentally friendly propulsion system, combining refined kerosene with hydrogen peroxide instead of toxic hypergolic fuels. Sierra Space has already begun work on a second vehicle named Reverence, which is being assembled at their Dream Factory in Colorado. With Tenacity scheduled to fly the first 4 missions and Reverence taking over from the 5th flight onward, Dream Chaser represents an exciting new chapter in space transportation, combining the best features of past spacecraft with modern innovations. The Atacama Cosmology Telescope in Chile has captured groundbreaking new images that give us our most detailed look yet at the infant universe. These remarkable baby pictures show the cosmos just 380,000 years after the Big Bang, revealing the universe's first steps toward forming stars and galaxies with unprecedented clarity. The images capture what's known as the cosmic microwave background, the afterglow of the first light that was able to travel freely through space. Before this moment, the universe was so hot and dense that light couldn't move without being scattered by free electrons. But as the cosmos expanded and cooled, atoms formed and light could finally travel unimpeded through space. What makes these new observations so special is their extraordinary precision. The telescope's images are 5 times sharper than previous observations and show both the intensity and polarization of this ancient light. This allows scientists to see not just where matter was located in the early universe, but how it was moving. The data reveals subtle variations in density and velocity of the primordial gases that filled the young cosmos. We can now see vast regions of higher and lower density extending millions of light years across. Over billions of years, gravity would pull these denser regions inward, eventually leading to the formation of the first stars and galaxies. These findings have helped validate our standard model of cosmology, showing it to be remarkably robust. The observations indicate that the observable universe extends about 50 billion light years in all directions, with a total mass equivalent to about 2 trillion suns. Of this cosmic inventory, ordinary matter makes up only about 5%, while dark matter accounts for about 26%, and the mysterious dark energy comprises the remaining 69%. The images provide an unprecedented window into our cosmic origins, allowing us to witness the universe taking its very first steps toward becoming the rich and complex cosmos we see today. Next up, a subject we keep revisiting, but one we all have an interest in. Recent research has revealed an intriguing new theory about how life might have emerged on Earth. Scientists at Stanford University have discovered that microlightning, tiny electrical discharges between water droplets, could have provided the spark needed to create life's building blocks. This challenges the traditional view that only powerful atmospheric lightning could have triggered these crucial chemical reactions. When water droplets separate through splashing or spraying, they develop different electrical charges. Larger drops tend to become positively charged, while smaller ones take on negative charges. When these oppositely charged droplets come close together, they create microscopic lightning strikes. These tiny electrical discharges appear capable of producing the same organic molecules previously seen in famous origin of life experiments. The researchers demonstrated that this micro-lightning can create important carbon-nitrogen bonds and form compounds essential for life, including amino acids and components of RNA. This process could have been widespread on early Earth, occurring wherever water sprayed against rocks or in ocean waves, making it a more plausible mechanism for life's origins than rare lightning strikes. In other fascinating developments, a Seattle-based company called Interlune has announced ambitious plans to prospect the moon for helium-3. This rare isotope, currently valued at around $20 million per kilogram, could potentially power future nuclear fusion reactors. The moon's surface contains an estimated 1 million metric tons of helium-3, deposited there over billions of years by solar winds. Interlune plans to launch their Prospect Moon mission in 2027, equipped with specialized systems to sample and process lunar regolith. They'll focus on areas rich in a mineral called ilmenite, which tends to trap helium-3. The company aims to demonstrate the feasibility of extracting this valuable resource, while contributing important scientific data about the moon's composition. And that's all for today's episode of Astronomy Daily. If you'd like to dive deeper into any of these fascinating stories, head over to astronomydaily.io, where you can listen to all our episodes and stay up to date with our constantly updating newsfeed of the latest space and astronomy developments. Don't forget to join our thriving community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, TikTok, and Instagram. This is Anna. Thank you for sharing in today's journey through the cosmos. Until next time, keep looking up and wondering about the mysteries that await us in the vast expanse of space.